Good day, students and viewers. I am Abdulaziz Idris, your regular Math 103 teacher. Today we are going to look at addition formulas for sine, cosine, and tan. We look at the diagram just drawn. The figure contains basically two right-angled triangles. The triangle OPQ and the triangle OQN. Upon construction, from including the dotted lines, we have additional two right-angled triangles, namely triangle OPM and triangle PRQ. Now, let us take the sign A plus B. We look at angle A plus B from the left-hand side in the bottom of the figure. Angle A plus angle B meeting at a point O. So the sign of that angle, we are going to consider the triangle OPM in terms of this triangle, in terms of this sine function for the two angles, the sum of the angles, A plus B. Now, it is opposite over hypotenuse, and opposite to A plus B is line PM over hypotenuse, and the hypotenuse is OP to that angle. Now, so sine A plus B is MP over OP, but MP is the same thing as MR plus line RP from the figure, because it's a dotted line that is broken into two. RP and then MR over OP now. Now the second line says that NQ is the same thing as RMR. Look at the line NQ. It's the same thing as RM. Look at the line. This line is the same thing as this line. Their height, the height of this NQ is the same thing as the height of line RM or MR. Now, the line, so you divide it by OP. RP is still maintained. Now, it's a common denominator, OP. Now you can separate NQ over OP plus RP over OP. That's a common denominator we are now separating. But if you look at NQ over OP, you can still multiply it by a product and say OQ and still divide by OQ. Similarly, you can multiply RP over OP by PQ and divide it by PQ, which is the same. So that if PQ should cancel PQ, you are back to RP over OP. And if OQ should cancel OQ, you are back to NQ over OP. But line OQ is the one here. The line OQ. This is the line OQ we are referring to. Now, we look at it again. So if you say NQ over OQ and OQ over OP, so NQ over OQ, look at NQ over OQ, which is opposite over hypotenuse of A, and that is equals to sine A. Also look at OQ over OP, OQ over OP, and that is equals to adjacent over hypotenuse of B, and that which is equals to cos B. That's the cosine function of B. Then plus RP over PQ. Look at the line RP, the line RP, this line RP over the line PQ. This is the line PQ. RP over PQ, and that's cos A, because this is A, but RP is opposite to A, this RQ is opposite to A, and then this is over adjacent, and that is equals to cos A. Now, you also look at the other one, times PQ over OP. PQ over OP, look at PQ, the line PQ over OP. This is OP. So this is opposite to B over hypotenuse of this B. And that's equals to sine B. So this is equals to sine B. And that is why you have here sine A cos B plus cos A sine B. And that is the sine function of the angles A plus B. Similarly, if you look at the right hand side, cos A plus B is equals to OM over OP. Where is OM? This is the line OM over the line OP, and that is adjacent over hypotenuse, which is equals to cos, and that is equals to cos A plus B. We are here, and that is equals to cos A plus B. So, but ON minus MN is the same thing as OM. Look at this ON. This is ON minus MN, this line. And that is the meaning of OM, the short line here, OM. It's when you have the whole ON, then minus OM, that is what will give us the line OM over OP still. So now ON minus RQ. So now MN is the same thing as RQ. Look at it here. The line MN is the same thing as the line RQ, as you can see, because they are of equal length. So we can simply substitute MN by RQ. You can use RQ in place of MN because they are the same, because they are the same in length. They are equal in length. And so we can now separate the common denominator ON over OP and then minus RQ over OP. But we can multiply by a factor and divide by it, which is OQ. And then we put the minus and still multiply the other operand by PQ over PQ. When you multiply and divide, it's like we have not done anything. We can still cancel and go back to the previous equation. If we can say this cancel this, and we can say PQ cancel PQ. And we are back to ON over OP and then minus RQ over OP, which is the equation, the previous equation. Now, what is ON over OQ? Where is ON? This is ON over OQ. This is OQ. So it is adjacent over hypotenuse of A, and that is equals to cos A. That is why we have cos A here. And then OQ times OQ divided by OP. This is OQ divided by OP. This is OP. And that is equals to opposite over hypotenuse of the angle B. And that is equals to cos B. That is why we have cos B here. Minus the minus we have here. So we have RQ over PQ. This is RQ divided by PQ. And that is like you are turning the triangle to the, let's say, to an angle degree 90 degrees angle. Now, that gives the opposite over hypotenuse of angle A. This angle A. This is opposite over hypotenuse of this angle A. And that is equals to sine A. That is why we have sine A here. Now, we have times PQ over OP. This is PQ over OP. And that is equals to opposite over hypotenuse of B. And that is equals to sine B, as we have here. So therefore, cos A plus B is equals to cos A cos B minus sine A sine B, as we have in equation 12. Similarly, sine A plus B is equals to sine A cos B plus cos A sine B. And that gives us the two formulas we have in 12 and 11. You can still replace B by minus B. If we replace the angle B by minus B, because the angle here, the minus B, cannot be preserved by the cos function, because a cos function is an even function. So therefore, it does not reserve negative. It swallows a negative sign. So therefore, replacing B by minus B, you have in equation 13 here that sine A minus B is equals to sine A sine B, because we have sine A here is positive. What cos B? Cos minus B is the same thing as cos B, because cosine function is an even function, so it swallows the negative. Minus cos A sine B. Why do we have minus here now in equation 13, whereas it is not in equation 11? The reason is that the sine function of B, sine B, because B is negative, so the sine of minus B is the same thing as minus sine B. So it preserves the negative. That is why we have minus in equation 13. Similarly, in equation 14, we have cos A minus B. We use equation 12 and put B equals to minus B. Instead of B, you have minus B here, and then we compute similarly. So we have cos A, which there is no substitution. Cos B, B is positive. Cos minus B is the same thing as cos B. And then plus sine A sine B in equation 14. Because there is a minus here, so sine B is the same thing as minus sine B. So we have minus in the original equation, and therefore we have minus sine B, and that is why in equation 14 we have plus here in the middle. The four identities are called addition formulas for sine and cosine. We can also obtain addition formula for tan, because we know sine of a function, the sine function is the same thing as, the tan function is the same thing as sine over cosine of any angle. Therefore, tan A plus B is going to be sine A plus B over cos A plus B as usual. Now, what is sine A plus B? We use the equation 11. So we use equation 11, this equation, in sine A plus B. And we use equation 12 in cos A plus B. So we replace sine A plus B with sine A cos B plus cos A sine B. And similarly, we do it for equation 12. And that is going to give us sine A cos B over cos A cos B plus cos A sine B over cos A cos B. That is divided by this equation. In this equation here, the division here is the division line we have in this equation. Readers should also observe that sine A cos B is this sine A cos B plus cos A sine B. This is cos A sine B. We decided to multiply by cos A cos B, cos A cos B. Here is cos A cos B, sine A sine B. So what happened here is that we decided to give this, instead here we multiply it by cos A cos B over cos A cos B. And that is what affects the denominators here. Cos A cos B, cos A cos B, cos A cos B, cos A cos B. And so this equation becomes sine A cos B, sine A cos B over cos A cos B, and then cos B cancel cos B, and then similarly here cos B cancel cos B. What we have, and then cos A cancel cos A, and that is equal to 1. So it is 1 now. Here you have 1 minus sine A over cos A, sine B over cos B, and that is equals to tan A, tan B. That is what we have here, tan B, tan A, tan B. Is 1 minus tan A, tan B. The division line is this division. This division is the division line used here. And this is 1 minus tan A, tan B. So this is 1 minus tan A, tan B. While the numerator, this is tan A, this is tan plus tan B. So you have tan A plus tan B divided by, so the division line, 1 minus tan A, tan B. Thus, we have tan A plus B is equals to tan A plus tan B over 1 minus tan A tan B. We can simply replace this B by minus B in this identity, and we have, instead of tan A plus B, you are going to have tan A minus B, and that's going to be tan A. There's no substitution there, it remains tan A. So it's going to be minus tan B, because tan B is the same thing as cos B or sine B over cos B. So even if the cosine retain, the sine function will still retain the negative, and that is why you have negative here. That is why you have negative here, because there is sine function involved. So this is over 1 plus tan A tan B. Because tan B has a negative, so it affects the negative here. Negative, it becomes positive. And that is why you have this positive. At this point, I'll pause here, and in our next attempt, we'll take example. Thank you very much.